Okay. Please, Trevor. The Additive Property.
Yeah.
Trevor, I think I broke my big toe.
Doing what?
I don't know.
Anything else? What do you mean, Ryan?
Because where I put my, like, the tip of my toe hurt earlier this week, and now my, like, the whole toe hurts. It's weird.
Maybe you need to see a doctor.
Yeah, I am a doctor.
Okay, so you stay at work, right? Done with work, right?
Wait, you work at McDonald's?
You
Oh, that's right. Ben, why'd you quit that? Your best friend worked there.
Because party sucks.
It does, it really does. But yeah, okay, so you know how I'm short shift, right? I work from 5 to 8. So it was like 4:50. I got told before I even started working.
Why?
Because Connor White, he was gonna hurt. He was gonna rush whatever. So I'm like, okay, well I'll help him. I'm nice. Cause like, so we only one time. He was using his phone, right? I put the pen in my cell.
I do that all the time. I do that all the time.
You love me.
What did she say?
She's like, I'm using your hands like this. You know, he's using it. And
You should have walked back to the rack and done another one.
Well, he was in a rush. The other one was standing there doing nothing for it.
Well, of course.
He's waiting for his hat.
Oh, he worked at here, I forgot.
He's got his hat at home.
I held it one too.
Like,
I never held one. That made us satisfied.
Did you just take a picture of me? I think she did.
You cool. Okay.
Oh, I did the picture
That's what I'm saying. Picture of me.
Alrighty, welcome back. If you were gone yesterday, I think it was only Woody here. Let's see, who else is gone? Not that a minute. So hopefully you turned in your page 130 already. That was the one that was due yesterday. So, all right, today we're going to do a few notes on the properties, which they were on the board yesterday, and I'll give the sub credit. He's got wonderful penmanship. I'll give him that. It's way better than mine, but really small. So let's do a couple notes today on proofs and algebra proofs, and we'll see how well you know it today. That's going to be our check to see whether you kind of know what we're doing here. I'm going to put some properties on the board, the ones that we were talking about yesterday and on Tuesday this week, to see if you kind of remember. That's kind of the idea. We'll talk about them. We'll see how well we know this stuff. Into this, not for a while. We're only like midway through chapter 2. I think this section is actually the exact halfway. They have like maybe 3 or 4 more sections. I don't know, maybe a week and a half. Come on, come on. Okay. Now. Okay, these are the properties of equality. These were the main properties we were to discuss yesterday. Now, there's a couple ones I do want to talk about. Ones that appears back up here. But again, the section we're in section 2.6. So I'd say probably for us, we have a test, maybe a week and a half, something like that. Because we still have to finish section 2.6 and we have to go into 2.7, 2.8, which is kind of the same style. They're still doing proofs. We'll get to more algebra style proofs on that stuff and kind of mix some stuff together. But again, we're dealing with algebraic proofs, right? Can you prove why an algebra problem simplifies the way that it does? Now, we're starting really small here. We're not doing billions of properties like I showed you on Tuesday. We're going to keep it very simple. Do you know the basic properties for right now? We're going to start small and we work up so that by the end of next week, you know the majority of them. Now, the majority of the properties that we learn come from the field properties, the ones that we did not discuss yesterday. So the sub should have just went through these, correct? Those basic ones. We had reflexive, symmetric, transitive, and then the additive property, multiplicative, subtraction, division, property of equality. Okay, and we'll talk about how we're going to use these. So, like, how would this work for a homework problem? What do you need to be able to handle? Okay. Now, there's a couple others, but they're not actually properties of equality. They're actually field properties, distribution, and substitution. So there's like the two main ones that I noticed that are in your book under this chapter, this section, but they're not actually properties of equality. So, but again, goal today: properties of equality. So we'll talk about these main 7 here. Then we're going to add 2 other properties to it so that we're comfortable. We're going to add distribution and substitution. And those are going to be the 2. And those are actually field properties. So these are going to be the main ones we're going to cover today so that we can see examples of these things. Okay? So the goal today is do examples where you should be hopefully somewhat comfortable with how the homework looks. Okay? So that's what we're going to do. That's what we're going to attempt to do today. But first thing that I want to talk about is this idea of reflexive property. That was one that I think in the notes yesterday I said that we're going to discuss later. I think that's all I wrote on there because it's hard to like put it down in the paper what I mean by that. So let's start there and we'll kind of work our way through these so that you know, especially obviously I do want to talk about this one, but the main one I want to make sure that you understand is this little guy right here, the transitive property. Transitive property can be really tricky on the way that it looks, and I want to make sure that you understand the difference between transitive and substitution. There's a clear difference. So that's what we're going to talk about. All right, but let's actually work through these. I'll start with the reflexive property. Okay, this is kind of what that little example shows you. A equals A, or 4 equals 4. Now, do you agree that's an equation? This one right here. Why?
Yeah, so that's an equal sign.
Perfect. Got an equal sign. It's an equation. Now, what makes it reflexive? You have one item equal to its exact self. Same thing, both left and right. You're probably wondering, why would you ever set a problem up like that? It seems goofy. No one does that. This is basically what happens. When I give you a math problem, like whatever it is, let's say it was like 7x plus 2 plus 5x, right? What most people do, if I write that on the board, they immediately copy it into their notes, correct? Like you write it down in your notes. You're actually doing your reflexive property. You're writing the exact same thing on your paper somewhere, okay? But what I do in like geometry is when you see this, I write it down. Over to the right of it, over on this side, I write the exact same thing down. And I know that seems a little goofy. I'm not actually trying to set up an equation where I'm going to like move things right and left. Because if you do that, you'll get 0 equals 0, and I don't want that. Because if you start dragging things across, they start canceling out. What I'm doing here is I start with reflexive. I start with the reflexive property. Because what I'm going to do is I'm going to work with this side only and simplify it down. That's what I'm going to do. So that's what we use reflexive property for. You set something equal to itself, and then you work with one side only, and you simplify it so that you can see what is this thing going to mold into. Now, the reason why you do that is so that you can compare what you started with versus what you ended with. That type of thing. It's a comparison. So that's why we use reflexive. Now, later on for geometry, for like the shapes and stuff, why we never use reflexive is when there's a certain piece of a picture you're going to use, but it wasn't anywhere else in the proof. Like, oh, I need to use this one wall. This wall has a number ID. Like I'm adding the walls together. Well, I've used the other walls so far to prove like certain walls are equal, but I need this random third wall. It's the one wall of the picture I didn't use. So you use the reflexive property, this one, to state that this wall is equal to itself. So that you're like, it's like you're introducing this item into the problem. Hey, this is the wall I'm going to use, and then later on you'd actually use it somehow, that type of thing. So it'll make more sense to you, trust me. A lot of people from geometry classes, once you get a sense for how reflexive property works in a geometry problem, it makes a lot of sense. But that's the start of it. Does that make sense now? So we start there, we can work our way down. That would be the other properties that you're actually simplifying. Okay, so that's what I wanted to talk about yesterday. Symmetric. Symmetric is not commutative. So maybe I should make a note here. It is not the commutative property. I think I introduced the commutative property the other day. Commutative, if you don't know, like on this problem over here, if I'm working with this wall, like this side over here, this right side, I would move the 7x and the 5x together, and I'd move the 2 at the back, right? That's commutative. That's not what symmetric is. Because all this is doing is rearranging things. That's commutative, right? What symmetric does is it takes whatever the right and left side of your problem and flips it. It's what you use in Algebra 1. So in Algebra 1, when you had a problem like this, like 12 equals 3x minus 6, right? You had a problem like that. Well, in algebra class, well, from what I can remember, is that most people, like, they switched around. Because, like, me personally, I always like to have the variable on the left side. I have no idea why. It doesn't make any difference, but I always just put the variable on the left. So the idea is that you can automatically start this problem. So this is my original equation. The next line, I can write this. I can switch the entire right and left side. Switch them around. And it's still the same problem. It's the exact same problem still. That's symmetric property. That's this. It's not commutative. Commutative is when you move things on one side around. So like over here, commutative would be just switching these two things around. Like putting the -6 up here, putting the 3 in the back. It's not moving the entire, like, across, it's not moving the entire side across an equal sign like this is doing. Like the right and left side are moving. Okay, so that's symmetric property. I just do that like on an algebra problem so that I always have a certain variable on the left. You do it for linear equations. If you remember back in algebra class, like problems like this. It almost looks like slope-intercept form back in algebra 1. But you switch around, you put the 1 on this side. So now you can graph it, right? Or this is your slope, this is your y-intercept, y equals mx plus b, and then you can graph from there. Right? So that's symmetric property. It's just a start. Now, what most people always get confused by is, because, like, if you look at that picture, did anything, like, change signs? Did it go, like, positive and negative on this problem? No. And that's the part that always weirds people out. It's like, well, I thought when you move things across an equal sign, it becomes, like, opposites, right? You add it or you subtract it. On symmetric, you change nothing. The reason being is that if you were to move everything would become the opposite. So like if you're thinking about it, like some people would do this. They'd subtract the 3x over, they would subtract, or they would add the 6 across, they would subtract the 12. Well, it doesn't look like what I have written here. So what they do is you divide everything by -1, because that's a division property, and it actually turns to this. If you divide everything by -1. But this is symmetric. You go from there to there. It's an if-then statement. If the top line, then the bottom line. Okay, questions on symmetry? Okay, very good. Transitive property. This is the one that I wanted to spend some time on. I want to show you the difference between transitive versus just substitute. There's a difference. Okay? Alright, so let's start with that. Start with this idea of transitive. I'll give you the sentence. Now, I know there's a sentence on the page there, on that kind of notes. But I want to talk about the difference between that and substitution. We have x plus 2 is equal to m, and m is equal to 8. Then x plus 2 equals you're looking at here, this sentence is transitive property. It's connecting the dots. So if you remember back, what I talked about, I think on Tuesday when I was introducing transitive and other properties, it was something like, we know that two students are the same age, one's 15, well then that means the other one's 15, because you said they're the same age. You're connecting dots. Well, on this part, I started with a random formula, right? This equation, x plus 2 equals m. And you also know that m is equal to 8. So what you do is you make connections in your head. Well, if that's 8, over here, this would also be equal to 8, because they're equal, m is equal to that. So you make this. That's transitive. You're making connections like, oh, these two equations share something, so they literally are equal to each other, that type of thing. Okay? Does that make sense? That's transitive. How substitution works, it's different. Substitution is this. If the angle, let's say angle y is equal to 4 and angle z is equal to 4, then angle y is equal to angle z. That's substituting. Because what you're doing here is you're not making the string of different equations instead of equal. What you're noticing is that they're equal to the same number. So this is equal to this thing, where you're literally substituting out the 4 here. Like there was a 4 here. And you're actually taking it out and you're plugging in something of equal value, the z, into it. The weird part is, would you agree, it looks identical to the top line. Like they look like the same problem, like, and it's super hard to explain this. Here's the difference. And I think the best way to explain it is actually using, it's using this part right here. It's the way that they have, it's the order that they have them written. Okay? So, A is equal to B, and then in the next line, you start with the B, this part. B is equal to something new. Then what you do is you make the connections between the first and the last thing. Well, over here, the difference is, okay, I had y equals 4, right? So this would be A equals B. Did I start with B right here? No. So that's the difference. There's the difference in substitution. Substitution, it's not, we didn't start with like 4 equals something else. So like, it wasn't switched around. It's just literally taking something and plugging an equal value in. It looks so much like transitive property that literally, like if you put it on a test, like, oh, I thought it was transitive, I probably wouldn't even count it wrong because they're so closely related. The only subtle difference is on transitive, you're connecting dots between two things that seem completely random. You know, like this x plus 2 is equal to something, and this new thing is equal to something random else, and then you make the connection, like the first and last thing are equal. As opposed to substitution, you're just plugging in something you value. Substitution, typically for substitution, you're doing it for simple arithmetic. So like on substitution, it's literally like on a problem, if you had this, x equals 4 plus 6, and in the next line you wrote just 10. You substituted, you plug something of equal value in there. It was usually we reserve it for any basic operation. So like adding, subtracting, multiplying, dividing. But not adding 0, that's a property, and not adding its opposite to make 0, or dividing by the same number, like dividing 3 by 3 and getting 1. Those are special properties. And any other type of math that doesn't create the number 1 or 0, that's kind of the telltale sign. That's usually where you see substitution. Just doing something simple that you made up that's new. That's why this is so difficult to explain. It's the order they have it written, number 1. Number 2, are you plugging something of equal value? All right. I don't know if that helped you at all. Maybe just confused you more. So just think substitution is simple arithmetic. Are you doing some simple math and plugging it? That would be good. All right. The last 4, these last 4 properties, they actually have the words property of equality after them. I'm just going to write it. So like addition, property of equality. This is, they call it multiplication in the book, but it's multiplicative. That's where I've seen every other book. multiplicative property equality, subtraction property equality, or quotient or division property equality. That's where you go on a problem and you magically do something to both sides. So, you know, they went from this problem, x plus 4 equals 10, and in the next line, like skipping some basic properties, but in the next line they simply just write this. How'd they go from here to here? What'd they do? That's this. It's subtraction property equality. Do you agree that they did to both sides? They magically subtracted 4 from the left, subtracted 4 from the right, and they literally got to that. You don't need to do all the properties today. I'm not worried about, oh, you know, we did property of opposites, and then we did, you know, we did an identity. We don't need to worry about that. Today, can you just identify the main thing they did? Oh, they did subtraction property equality. So you write subtraction prop equality. Like, you're just identifying the main thing they did. Okay, that's the idea. All right. Here's another goofy one. Give me any random number. 7. Okay. And suddenly going from this to your top line. I know that's weird. You start with this. In the next line, they suddenly do this. What do they magically do? From the top line to the bottom line, what do they do? Yeah, they created an equation, right? It looks like they created some type of math problem. But what do they do to both sides? Added 2, right? That's your property. They added 2 to both sides. That's the additive property equality. It's this one. That's a big one. They're magically adding numbers. So what they're gonna do for most of your homework problems, they're gonna give you a simple line, one simple line, and they're gonna say, hey, what was the one property that they're doing here? Oh, they're magically adding to both sides. So it's additive property equality. Or maybe they did this, here to here. Well, they subtracted, so you write subtraction property equality. You're just identifying one property. There's only a select few, like, if I can think back, I think there's 3 problems that you're going to have to do where you have to actually write somewhat proof of it. Like where you have to just show the basic work. So something like this, where it's this. 5x minus 2x plus 3 equals let's go 13. Actually, no. Let's go 50. That work? Yeah, that'll work. All right. So like this is the problem, and they're going to ask you, okay, write the 2-column proof that proves that problem. So let me get rid of this. All right. So let's say this is our problem. I want you to prove it. You don't need to give me every, like, all 8 lines of this problem. All I want you to do is just do shortcuts. So like, for instance, when you look at this problem, what's the first thing you would do? Subtract the 3 across? Okay, so we'll do that. So if we subtract the 3 across, what do you get? Minus 2x equals what? 12. Okay? So what did you magically do to both sides? You just said it a little bit ago. That's your property. So subtraction property equality. Prop of equality. Okay? Make sense so far? So you just give me like what is the basic thing you did? Don't worry about all the weird steps in between. So I want to start slow. We're going to start slow and work our way up to here. Okay, next one. 3x. That right there, that's substitution. That's substituting. You plug something of equal value in, because, do you agree, I didn't do something to both sides. If I did something to both sides, that would be a property equality. Like, oh, I naturally added something to both sides. I didn't. I did something to one side and replaced it. That's substitution. Simple arithmetic. That's all you have to write. We'll eventually film properties later. There's other things we can do. Okay? And now the last step. By 3. That's your property name. So my final answer here would be x equals 4, right? And that would be division property of equality. That's what I want you to do. Like, that's your proof today. you know your basic property names. Nothing real fancy. Don't overthink it. Now, there's a symbol I introduced yesterday, or the sub should have wrote on the board yesterday. Did the sub write this little symbol down? Yes. Okay. We put that at the end of a proof. It's the last line of your proof. The reason why, it signifies this is the end. This is what you're trying to prove. So maybe it's like the problem started with like, you're given 5x minus 2x plus 3 equals 15. And what we're trying to prove is that x equals 4. Maybe that's what we're trying to prove. So when you start a proof, like an algebraic proof or algebraic proof, you start with your lines going down and working your way down. This is the given line, by the way. Start with that. Start with your given line. Then you do some math, some basic stuff. And when you get to down to what you're trying to show, you put that little symbol up front. And all it means is therefore. Therefore, this is true. And as you're doing your work, you're just writing down the properties that you did. Oh, okay, I subtracted to both sides. Oh, I substituted. Oh, I divided to both sides. And then you're trying to the basic properties. Does that make sense? Don't overthink things. Because I know, like, if I go back to the slides, right? There's my cursor at. Oh, there it is. All right, so there's a ton of problems. I know. Don't overthink it. Don't overthink it. All right, I'm going to turn this into homework, which is really odd, right? Because all I want you to do is getting used to these basic properties. Now, distribution is the one where they have parentheses and distributing something over it. I think everyone recommends distribution. You might have that on a problem, but don't overthink it. We're not using the field properties. I'm not worrying about properties of opposites and multiplicative identities. None of those. And we just do the basic stuff. These 7 and these 2 are the basic properties you should know as of this moment. Okay? All right. I'm going to turn you loose on homework. Here it is. This is due on Tuesday next week, and just some of those first problems. They just ask you what's the one property you're doing. That's it. That's all they ask for. If they ask you to actually write a proof or fill in the proof, because some of them they actually have the proof all written, they just want to know the property names, then you just have to kind of fill in the gaps on whatever proof it is. There's only I think there's 3 of them that you have to do yourself, like I just did. Okay, so here's your homework. It is page 139, 1 through 7, 9 through 20, and it's due Tuesday. I will give you some time on Monday to actually work on this, so we can actually talk about it. I might actually put a couple up on the board, especially the ones you have to prove yourself. See if we get them right. See if we... Okay, you can move around, but this is your homework. Okay, if you haven't turned in page 130, please put that in. We'll be handing out some homework on Monday, graded. So make sure that you got that turned in. That'll be my one day. Remember, those first couple, all they're asking for, what is the one property you're doing here?
online book. What's the website? Is that on your page?
Yeah, so if you go to the
Okay.
website, you click geometry, instead of like clicking a lesson, it just says, oh, your online textbook's here.
Okay.
I need to put a box on it. Highlight it. That might help a little.
I don't think so because do you know when oh November 1st. If she says well, this is the first one. That next one's the first one.
Your first dot last name, but capital letter for first, capital letter for second.
Oh, it was the
Dude,
first
what's their
one.
username and stuff to get into there?
First name, dot last name, capital letter.
And then what about the bathroom job?
Cards 1, 2, 3.
Oh, what?
Cards 1, 2, 3.
Cards.
I always forget that. I should just put the instructions first.
I don't know how.
Question again. Subtraction. Subtraction property. Yeah, that's fine. Yeah, so if it's subtraction, put subtraction property. The other ones are fine. Like, if you're just writing transitive, I'm good with that.
Yesterday, you were going to and I was driving. He did. He was looking at me. Well, I did those two in the same day. Because then you're there. That shows. I did that.
Out of here early for any reason there.
Nope, no. I think 6, 7, 8, 9 are shortened, I think.
Like 3 or 4.
Right?
Because the background.
Yeah.
Yeah.
So for number 4.
Yeah. At least here when they do.
Sorry, I thought that was
I could add
Wait. No, that's a big bad. Let's do
I just wrote 2 paragraphs for 8. I was hard to hold the other day. Because he was playing his film music, and I was like, forget it's just a viewer. And he's like, okay, first of all, how do you go from the computer just to be here? Everybody was just doing the transcript. So common was over at the small chocolate.
Oh, one is,